Hello and welcome to Swan Science. I am Scientist Swan, your favourite scientist. Now today, boys and girls, we're talking about the Dippy Bird. Now I'm not talking about your wife or your girlfriend, I'm talking about this Dippy Bird, or some people refer to it as a drinking bird. Now this is a very amazing experiment. Basically the bird can drink all on its own. But what I'm going to do to you today is tell you how it works. First of all, I'm just going to let his head dip before I explain to you, and there he dips. Now if I just take him off here, first of all, what we've got here is we've got a stand for the bird, if I just unclip him from there, and we've got some liquid in this glass jar here. We've got a head at the top that's covered in felt, and we've got some liquid. Now the liquid is methylene chloride, which has a very low boiling temperature, particularly in this jar, because this jar is held at a vacuum. Now ordinarily this liquid boils at 39 degrees Celsius. So what actually I can do is, if you see there, I can actually make it boil just through the heat of my hand. In a minute you'll see bubbles coming up, and just give that a minute. There it is boiling. So it's very, very low boiling point of the water, of the liquid in there. That's methylene chloride. So now I'm just going to put him back on his stand. Now how this works, now to get this, once you receive your Dippy Bird, I got this one off a very well known auction site. First of all, you have to dip its head in water to soak the whole of the felt at the top. Now what actually happens to this bird is, I'm just going to let him swing down there, and then I can explain to you what, as it goes along, and swing it up there, is what happens is, because the head's wet, the water on the felt evaporates, and as that evaporates it takes heat out the top bulb, allowing so that as this is evaporating, heat is being removed from the bulb at the top, reducing the temperature, therefore reducing the pressure. That's causing a vacuum up here in the top, which is sucking the water up the tube from the bottom chamber to the top chamber. So as you can see again, as the water is evaporating, the heat's evaporating from the top, and therefore it's creating a vacuum, sucking up the liquid. And as the liquid gets sucked up, it makes the top of the bird top heavy. So the bird then becomes top heavy, and because of the pivot fulcrum, remember from physics, pivot fulcrum load, because of the pivot it gets top heavy and unbalanced, and therefore the head dips into the water. Now once it dips into the water, this allows an air brake here to allow the bottom pressure and the top pressure to equalize, allowing for the water to roll back down into the bottom chamber, and it all starts again. Now the water is important because the water keeps the top bit damp or wet. So that continues to keep the top part damp, because if the top part dried out, the water would no longer evaporate and no longer cool the top bulb, and therefore the whole process just stops. So the water is very important, and as you can see it dips. And this has been going for about 24-48 hours. Now some people may say that it is what you call a perpetual machine, but it's not, because it actually uses a lot more energy than it gives out. It uses about 500 milliwatts of energy in heat transfer, and it only gives out about 0.1 of a milliwatt. If you put, obviously you can put a magnet onto it, or you get power out of it, but it's less than 1% efficient. So it's not a perpetual motion machine. So, but that is our drinking bird. Ideal for kids. Make sure the kids are a bit older, because it is a vacuum, and obviously the liquid inside can be quite dangerous if the glass breaks and the liquid gets everywhere. So just be a bit careful, maybe for your older kids. But it's lovely to watch, and I'm just going to let you watch that for a few more minutes before I go. Thank you for watching. If you like this video, thumbs up, share it if you want. And this is Swan Science signing off. Love you all. Scientist Swan. Goodbye.